In 1962, Ryan Aeronautical Company joined with the United States Air Force under the Big Safari program to develop and produce Model 147 Special Purpose Reconnaissance Aircraft. The Jet Reconnaissance Drone, a relative newcomer to the military intelligence gathering inventory, has and is demonstrating its highly versatile ability to contribute to this vital military task. By August 1967, 13 versions of the Model 147 had been developed for use by the Strategic Air Command. A large proportion of 147 special purpose aircraft have been high-altitude versions. High-altitude reconnaissance aircraft have particular advantages in carrying out reconnaissance missions. Among these are greater photographic coverage, longer range, and less susceptibility to conventional ordnance or enemy air attack. In October 1962, Ryan was awarded a contract to build the 147B. The B was the first operational special-purpose unmanned reconnaissance aircraft delivered to the United States Air Force. On August 20, 1964, the 147B flew its first operational mission. Ryan Aeronautical Company produced 37 147Bs, which flew 76 operational missions during their lifespan. The B was the forerunner of our present and future high-altitude special-purpose aircraft, equipped with the J-69 T-29 engine and HICON 233A camera. The B's successor as a high-altitude special-purpose aircraft was the 147G. The first of 56 147Gs was delivered to the Air Force on 9 July 1965. The G began making operational flights in October 1965. By August 15, 1967, the 147Gs had completed 77 operational missions. The most significant change in the G, giving it both a higher rollover point and higher altitude, was the introduction of the J-69 T-41A engine, giving it an increase of 220 pounds in thrust. In July 1965, Headquarters Air Force Logistics Command authorized Ryan to begin production of the 147H. This is the story of the H, a particularly new concept in high-altitude special-purpose aircraft. The 147H is designed to fly higher and further than either of its predecessors. The H, equipped with a modified J-69 T-41A engine and a HICON 338A camera, is the latest operational high-altitude special-purpose aircraft in the inventory of the United States Air Force. The comparative trend of improved high-altitude performance has permitted each new 147 high-altitude version to achieve a higher rollover point and higher altitude over mission areas. To meet the mission altitude specifications desired by the Air Force for the H, required development of new concepts in aerodynamic smoothness in its design. The Air Force required that the 147H achieve a new level of interchangeability to facilitate operations and maintenance in the field. The H was to be developed so that it would have less weight and be primarily air retrievable. The Ryan Aeronautical Company undertook a major design effort to make this complex, sophisticated drone meet the challenge of its mission requirements. Once in production, the 147H would have many improvements. It would have improved roll control. It would have a post-recovery locator beacon. It would be equipped with contrail suppression and special ECM devices. The H would be the first 147 special-purpose aircraft with fuel-carrying capability in its wing to give it the longer range and higher altitude performance necessary to meet the mission requirements. The 147H would be the most complex special-purpose aircraft developed by the Ryan Aeronautical Company for the 147 program. One of its many added capabilities would be called Rivet Bounder, a sophisticated electronic countermeasure device designed to jam the SA-2 guidance system. A second innovation in later versions of the H is HIDE, High Absorbency Integrated Defense Against Electronic Warfare, developed by the North American Aviation Company. HIDE is installed in the air intake duct assembly and air inlet nose duct fairing to reduce radar reflectivity of the special purpose aircraft while in a hostile environment. Radar detectability, hence survivability, is a critical facet of the 147 vehicle's ability to penetrate and perform its mission in a hostile region. Using HIDE, there is a demonstrated reduction in nose-on attitude of 7.5 decibels in X-band frequency, 8.0 in S-band frequency, and 7.5 in C-band. A third innovation connected with the improvement of the H's survivability is HEMP, H Evasive Maneuver Program. HEMP, designed by Ryan and Melpar Corporation, is intended to give the H the ability to evade high-altitude detection and destruction by MiG aircraft. The installed HEMP system, with its array of antennas and control boxes, is so designed that when alarmed by an airborne fire control radar, the H will make programmed turns to elude its attacker. After extensive flight tests at the Pacific Missile Range, Point Mugu, California, the H was ready for delivery in December 1966. All special-purpose aircraft, once qualified, are delivered initially to the 100th Strategic Reconnaissance Wing at Davis-Monthan Air Force Base in Arizona. Here they are operationally tested and repackaged for final shipment to Operating Location 20. This 147H will be transported non-stop to Vietnam on a C-141 Starlifter. Operating Location 20 is a SAC organization at Bien Hoa Air Base in the Republic of Vietnam. On its arrival at Bien Hoa, the 147H joins other members of the 147 family, the J, the NX, and the G, and is immediately prepared to carry out reconnaissance missions in Vietnam. The H is removed from shipping crates and the individual airframe components assembled so that the H can be readied for operational launch. The wing is rolled into position under the suspended fuselage. The fuselage is carefully lowered into position over the wing for attachment. The assembled wing, fuselage, empennage, with the engine installed, are prepared for final assembly and systems checkout. The Hycon 338A camera, the H's reason for being, is bench checked and installed. The assembled special-purpose aircraft then begins electrical flight control and Doppler subsystems test following detailed formal checklist procedures. Final airframe assembly is accomplished, and the H is ready to be uploaded onto a DC-130 launch aircraft. The SPA is now ready for mission programming. A mission briefing is conducted to establish launch points, routing, weather data, and all other information required for mission planning. The mission is then converted to program commands for the H. Final pre-flight checks are accomplished by the launch control officers. The system is ready for flight. Shortly after takeoff, pre-launch checks commence and are conducted en route to the launch point. The flight control system is tested for airframe response. The Doppler system is checked for proper drift angle and ground velocity indications. Final navigational updating is accomplished. At launch, the vehicle becomes an operational reconnaissance drone. Over the mission area, the 147H, equipped with a 338A Hycon camera, will begin its intelligence gathering task. Flying at its mission altitude, the 338A is capable of scanning an area 783 nautical miles long and 22 nautical miles wide. Despite this high altitude, the 338A will return data of amazing clarity and detail. At the recovery site, all systems are alerted for the return of the vehicle. CH-3C retrieval helicopters will be scrambled. A TPW-2 MCGS radar will begin searching. When recovery is commanded, the H will descend in its chute, and the helicopter will be vectored into position for a mid-air retrieval. The CH-3C usually makes engagements between 8 and 11,000 feet. Once engaged, the main chute falls away automatically, and the vehicle is then ready to be reeled into a stowed position and returned to the recovery base. At Thompson Newt Air Force Base, photo interpreters will stand by for the return of the film, where it will be processed and primary evaluation accomplished at SAC-SARF within 12 hours. The vehicle returns to Benoit on the pylon of a C-130 for turnaround rehabilitation and readiness for another reconnaissance mission. The completed mission will be carefully debriefed so that every aspect of the flight has been evaluated and understood by all the participants. Turnaround complete, a new mission assigned, and the Model 147 Special Reconnaissance Aircraft sets out to gather the needed intelligence information.